The atomic theory proposes that a fixed proportion of electrons and protons exist in an atom. The nucleus contains positively charged protons while the negatively charged electrons orbit relative to the nucleus, which is better known as the electron cloud. In this example, we see induction by polarization when we bring a charged object, in this case the rod, near a neutral object, in this case the metal sphere. The negatively charged electrons in the rod and the positively charged protons of the metal sphere are attracted to one another by an electrostatic force. That means that the electrons of the metal sphere pile up on the opposite end of where the rod is due to a repulsive force, while the positive protons are attracted to the negatively charged electrons in the rod. Take for example this experiment. We rub a styrofoam cup with a dry rag. The cup becomes charged, causing the negatively charged electrons to accumulate on the end of the cup where we rubbed. Bringing the cup near a stream of tap water, we see that the water bends. This is because the tap water has been polarized. As the cup nears the water, the negatively charged electrons in the cup cause the water molecules to polarize. The positive hydrogen ions realign themselves to be closer to the negative charge of the cup, while the negative oxygen ions attempt to be repelled.
The same principle applies here. The polarized negative charges of the thin film of plastic wrapping paper polarize the styrofoam pieces, resulting in an attractive force that pulls the styrofoam pieces to the wrapping paper. This is another example of induction by polarization. By charging the bottle, we have polarized the negatively charged electrons to the end of where we rubbed. Bringing the bottle near the aluminum can induces polarization in the can, causing positive charges located in the nucleus to drift closer to the bottle. The net result is the can moving to an electrostatic force. But what happens to the rag if the bottle is negatively charged? The rag now becomes positively charged, resulting in the same outcome as the bottle, but with a significant difference. The positively charged rag polarizes the can when it is brought near the can, causing negative electrons in the can to polarize closer to the rag. This concludes that it's because of the polarization of objects that water bends, an aluminum can moves, or the styrofoam pieces pulling closer to the wrapping paper in this given context.